In this video, we're going to focus on balancing redox reactions, but within basic solutions. So what we're going to do first is we're going to balance it under acidic conditions, and then we're going to add hydroxide to both sides, and it's going to work out as if we balanced it under basic conditions. So let's begin. Let's start with this reaction. So zinc metal reacts with bromate to produce the zinc plus 2 cation and bromide. So under acidic conditions, what's the first thing we should do to balance this reaction? So the first thing we need to do, we need to separate this reaction into two half reactions. So let's start with zinc. Zinc is going to convert into the zinc plus 2 cation. Now the number of particles, or zinc particles, they're already balanced. We have one zinc particle on each side. So we need to balance the charge. The charge on the right side is 0, but the charge on the left side is plus 2. So the difference between these two numbers is 2. So we need to add 2 electrons, but we're going to add it to the side with the higher charge. So we're going to add it to the right. If we do that, the net charge on the left side and on the right side will be the same. It's going to equal a charge of 0. So now, let's balance the second half reaction. So bromate converting into bromide. Now to balance this half reaction under acidic conditions, we are allowed to add H plus and H2O to balance the atoms first. So we have 3 oxygen atoms on the left. Therefore, we're going to add 3 water molecules to the right side so that the number of oxygen atoms are the same. So we have 3 oxygen atoms on both sides right now. But by adding 3 water molecules, we've added 6 hydrogen atoms to the right side. So we need to add 6 H plus ions to the left side. Now once the number of particles or atoms are balanced to both sides, we can now balance the charges by adding electrons. The total charge on the right side is -1. The total charge on the left side, so we have 6 hydrogens each with a +1 charge. So 6 times 1 is +6, plus the negative charge from the bromate ion. So 6 and -1, the net charge on the left side is +5. So the difference between 5 and -1, if we subtract those two numbers, 5 minus -1, the difference is +6. So we need to add 6 electrons to the side with the higher oxidation state, or the higher charge. In this case, the left side. So now we've balanced the second half reaction. So now what do we need to do at this point? At this point, we need to balance the number of electrons. So notice that we have 6 electrons on the left and 2 electrons on the right. So let's multiply this equation by 3. So it's going to be, we're going to have 3 zinc atoms, 3 zinc cations, and now we're going to have 6 electrons. So if we add these two equations, the number of electrons will cancel. And so it's going to be 3Zn plus 6H plus Br, this is a 3, BrO3 minus, and that's going to turn into 3Zn plus 2 plus Br minus plus 3 water molecules. So this is the balanced reaction under acidic conditions. Now to get the answer under basic conditions, what we're going to do is we're going to add 6 hydroxide ions to both sides. The reason why we're going to add 6 is because we have 6 H plus ions. H plus OH minus will give you H2O. So let's add 6 hydroxides to the left side, and let's add 6 hydroxides to the right side. So on the left, we're going to have 3 zinc atoms. Now 6H plus 6 hydroxide ions is equal to 6 water molecules. And then we're going to have 1 bromate ion. And on the right, it's still going to be 3Zn2 plus plus Br minus, but we're also going to have 6 hydroxide ions and 3 H2O molecules. So now what we're going to do is we need to subtract both sides by 3 water molecules. Notice that we have H2O on both sides. So on the left side, we're going to take away 3 water molecules, and on the right side, we're going to take away 3. If you want to know why it's 3, you look at the number of water molecules on both sides. We have 6 on the left, 3 on the right, and then you want to subtract it by the smaller of these two values. So now we have our final answer, which is 3 Zn plus 3 H2O plus BrO3 minus bromate and 3 zinc 2 plus cations plus 6 hydroxide ions plus Br minus. So that's how you can balance a reaction under basic conditions. So if you notice, we have 3 zinc atoms on both sides. We have 6 hydrogen atoms, 1 bromine atom, and notice that we have a total of 6 oxygen atoms. 6 here, 3 in bromate, and 3 in water. So all of the atoms are balanced, and if you look at the net charge, notice that the net charge on both sides is the same. On the left side, the net charge is -1. On the right side, we have 3 times plus 2, which is plus 6, 6 times -1, which is -6, plus 6 and -6 is 0, and then we have a -1 charge from the bromide ion. So on both sides, the net charge is -1. So we know this reaction is balanced. The number of atoms are the same on both sides, and the total charge is the same on the left side and on the right side. So now let's try another example. So iron metal reacts with the perchlorate ion to produce Fe plus 3, or 3 plus the chloride ion. So go ahead and balance this reaction under basic conditions. Feel free to pause the video, try this example yourself, and then unpause it when you're ready. See if you get the right answer. So what we're going to do first is we're going to balance it under acidic conditions. So let's start with Fe. Fe turns into Fe plus 3. And we need to add 3 electrons to the right side to balance the charge. So we're done with that half reaction. Now let's start with the next half reaction. So perchlorate is going to turn into chloride. Now we're going to balance this under acidic conditions first. So we're going to start by adding water molecules. How many water molecules do we need to add to this reaction, and to which side should we add it to? Notice that we have more oxygen atoms on the left side. So we're going to add 4 water molecules on the right side so that the number of oxygens are balanced. But now notice that we have 8 hydrogen atoms on the right side. So we need to add 8 hydrogen atoms to the left side. So we're going to add it in the form of 8 H plus ions. Now the last thing we need to do for this half reaction is that we need to balance the number of electrons. So let's find the total charge on each side. On the right side, the total charge is -1. On the left side, we have 8 times 1, which is plus 8, plus the -1 charge from the perchlorate ion. So we have a net charge of +7 on the left side and -1 on the right side. So if we subtract these two numbers, 7 minus -1, that's the same as 7 plus 1. So the difference between these two numbers is 8, which means that we need to add 8 electrons to the second half reaction. So to which side should we add those 8 electrons? To the left side or to the right side? So keep in mind, always add the electrons to the side with the higher charge. So we're going to add it to the left side. And in the other half reaction, notice that the electrons are on the right side. So therefore, in the second half reaction, it has to be on the left side. They cannot both be on the same sides. Whenever the electrons are on the right side, the reaction is oxidation. You have an increase in oxidation state from 0 to +3, and you can see that iron is losing 3 electrons because it's on the right side. Whenever the electrons are on the left side, you have a reduction half reaction because it involves a gain of electrons. And notice that the oxidation state of chlorine decreases from 7 to -1, so it's a reductive process. Now that we have each half reaction balanced, now what we need to do next is we need to balance the number of electrons because they're unequal for this reaction. So how can we do that? So we have 3 electrons in the first half reaction and 8 in the second. The least common multiple between 3 and 8 is 24. So we're going to multiply the first one by 8 and the second one, or the second half reaction, by 3. So then what we're going to have now is going to be 8 Fe and 8 Fe3 plus 24 electrons. And here we're going to have 24 H plus 3 perchlorate ions plus 24 electrons, which is going to give us 3 chloride ions and 12 water molecules. So now what we're going to do is we're going to add the 2 half reactions together. But let's make some space first. The number of electrons is going to cancel. And so on the left, we're going to have 8 iron atoms plus 24 H plus ions and 3 perchlorate ions and 8 Fe3 plus cations and 3 chloride ions, and finally 12 H2O molecules. So notice that this reaction is balanced. We have 24 hydrogen atoms on both sides, 3 chlorine atoms, 12 oxygen atoms, and 8 iron atoms. And if we check the total charge, let's make sure it's the same on both sides. Here, this is plus 24, negative 3, and let's see, 8 times 3 is also 24, and we have a minus 3 from the 3 chloride ions. So as we can see, the total charge is the same on both sides. So we have the balanced reaction under acidic conditions. So now we wish to balance it under basic conditions. So what can help us to do that? What do we need to do at this point? At this point, we need to add hydroxide ions to the solution. So the number of hydroxide ions that you need to add is based on the number of H plus ions that you see in a balanced reaction. So we're going to add 24 hydroxide ions to both sides of this equation. So on the left side, 24 H plus 24 hydroxides is going to give us 24 water molecules. So we're going to have 8 Fe plus 24 H2O molecules, and then everything else is going to be the same. But on the right side, we're going to have an extra 24 hydroxide ions. Okay, so now, what is the next thing that we need to do? What's our next step? Notice that we have water on both sides, so we're going to subtract both sides by the smaller of these two values. So 12 is smaller than 24, so we're going to subtract both sides by 12 H2O molecules. So on the right side, H2O is going to disappear completely. So now we can write our final answer. So it's going to be 8 Fe plus 12 H2O plus 3 perchlorate ions, which yields 8 Fe3 plus cations plus 3 chloride ions, and then plus 24 hydroxide ions. So now it's balanced. This is our final balanced reaction under basic conditions. So we can see that we have 8 iron atoms on both sides. Here we have 3 times 4, 12 oxygen atoms, plus 12 here, and we have 24 oxygen atoms in the 24 hydroxide ions. And we have 3 chlorine atoms on both sides, and 12 times 2 is 24 hydrogen atoms. So the number of atoms are the same. Now let's check the net charge. The net charge on the left side is 3 times -1, so it's -3. On the right side, we have 8 times 3, which is plus 24, which cancels with the -24 from the 24 hydroxide ions. And we have a -3 charge from the 3 chloride ions. So the number of atoms and the charges are the same. So this is it. This is the final answer.